It's the world's first self-balancing, electrically powered personal transportation device. Built-in sensors and an onboard computer keep this vehicle upright as it zooms around up to 3 times faster than walking speed. Perfect for large warehouses, delivery routes, or anyone who just wants a lift. Tough, lightweight construction materials enable the transporter to safely take you almost anywhere. This aluminium chassis will house the vehicle's electronics. It can withstand an impact force equivalent to the weight of 3 large cars. Using a press, couplings are attached to 2 motors. These couplings will connect the motors to the gearboxes later on. For safety reasons, many of the transporter's components are doubled. Normally they'll share tasks equally, but any of the twin parts can do all of the work if the other fails. It's what the industry calls redundancy. Using 3 screws on each side, the motors are installed into the chassis. 2 controller boards are then installed in the top side of the chassis. Microprocessors in these boards control the motors. Something called the balance sensor assembly is added. This includes 5 gyroscopes and 2 components called fluid tilt sensors. These instruments gauge the vehicle's position relative to the ground. The controller boards check these instruments 100 times per second and adjust the vehicle by rolling the wheels forward or backwards when the rider leans. Wire clusters, called harnesses, connect the vehicle's batteries to the control shaft. The chassis cover doubles as a floor plate for the rider to stand on. The rider's weight will push 4 rubber buttons. These disrupt an optical beam on the controller board, telling the transporter it has a passenger. The harnesses fit through holes in the cover, which is attached with 8 screws. Next, the harnesses are connected to a power converter in the base of the control shaft. The power converter uses household electricity to recharge the batteries. Inside the gearbox, 4 gears transfer power from the motor and turn the wheels. The gear's teeth are cut at an angle, so they engage gradually and smoothly. This keeps the vehicle's noise to a relatively low hum. The gearboxes are secured to the chassis with a mallet. A waterproof rubber seal is opened and the machine's power cord is plugged in. The electrical system is tested. 5 screws are used to attach one of 2 plastic fenders. A tapered metal hub connects each wheel to its gearbox. A molded rubber and metal mat covers the floor plate and snaps into place on both fenders. The chassis is turned over and 2 batteries are connected to the controller boards. They can be recharged in a wall socket in about 8 hours. The transporter can travel almost 40 kilometers on a single charge. This machine tests the rider detect buttons by applying pressure in a random pattern. The rider and cargo must weigh between 45 and 118 kilos. The machine also tests the wheels and motors. Next, a handlebar is placed on the control shaft. Turning the hand grip left or right steers the transporter. The motor responds by spinning one wheel faster than the other. Spinning the wheels in opposite directions makes the vehicle pivot. Ignition keys with computer chips in them restrict travelling speeds for safety reasons. The keys also instruct the vehicle to make slow, medium or sharp turns. Now the fun part, taking each transporter for a test drive. The tester listens for unusual sounds and checks for vibrations coming from the gearboxes. The transporter is run up small inclines. It's designed to conquer slopes of up to 20 degrees. It gets down from a curb just as easily. Only after this thorough test drive is the transporter ready for its first real trip. And you're sure to have a really good time.
up. No, I don't take shit, I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.